First of all, I'd like to acknowledge that I'm hosting this session from the land of the Wurundjeri people of the Kulin Nation here in Melbourne, and I also want to acknowledge their elders, past, present, and emerging, and all the Aboriginal and Torres Strait Islander people participating in this event today. We're here to give you an overview of this big new project that A2EP and the Energy Efficiency Council are spearheading. Many of you on the call will know that both our organisations have had a really long-standing interest in this topic, in the role that heat pumps can play in improving efficiency and in lowering emissions and providing flexibility services to the grid. And we've watched as nations around the world have turned to heat pumps as one of the key tools in the decarbonisation toolbox. Now, in Australia, there's been a fair bit of work done on this topic by the EEC and A2EP and organisations like BZE and others. But when we talk to policymakers, it was always clear that there were some gaps still in the knowledge base. They always told us there were some key pieces of information that they really needed, and that filling those gaps would support good policy making on the role heat pumps can play right across the Aussie economy. And that's why earlier this year, our friends at DISA, the Department of Industry, Science, Energy and Resources, commissioned the EEC and A2EP to dig into this topic. So we're filling that gap, and we're looking at it, the topic from a high level, encompassing a number of sectors: residential, commercial, manufacturing, and agriculture. And our starting point is that we need to characterise the state of the market here in Australia in each of those sectors, and it varies quite a bit. Heat pump proliferation in residential relative to agriculture is completely different. They have different applications, so we need to be looking at this at a fairly granular level to support that good policy making. We also want to dig into supply chains to determine the availability of heat pumps for applications in each of those key sectors. We want to look at minimum standards for heat pumps to ensure customers have some confidence around things like performance and quality. And we want to look at the skills needs across trades and professions responsible for specifying and installing and commissioning heat pumps, because some of the early and strong feedback is that we've got a big job of work ahead of us just getting the key trades across heat pumps and how they are appropriately applied in each of those sectors. And this is really exciting and something that we'll be giving you a full briefing on today. We're also undertaking a modelling exercise to determine what ramping up heat pump deployment would achieve in terms of carbon emissions, productivity improvements, and energy cost savings. So our goal at the end of this period is to provide the Commonwealth with a really robust report that canvasses all of those issues and puts them, as well as state governments, in a very strong position to craft some targeted policies in each of those sectors that will see, heat pumps reach their full potential right across the Aussie economy. Now, we have a great project team across A2EP and EEC, many of whom will be joining us for the question and answer session in the second half of this webinar. However, to gather the input and insights that we need to make this report really impactful, we need to tap into experts right around the country. And we know many of you are here with us on this call, and we've indeed been hearing from you consistently since this project was announced. It's generated a huge amount of excitement among people that are passionate about this topic, which I personally find really exciting. And the first thing that we're going to ask you to do is respond to a survey. And that survey, if it's not already in the chat, will be in the chat very shortly. It's a short survey. It's just a few questions, but it'll really help us calibrate our thinking as we come out of the gate, and focus in on the areas that we need to as we go through the research process, the interview process with key experts. So I'd encourage you that while we obviously want you to hang on our every word, if you were to do something in the background, if you could fill out that survey while you're listening in, that would be deeply appreciated. And we'll circle back at the end of this hour and we'll give you a sneak peek of some of those early response we've got from all of you listening in. Okay, so beyond that, beyond the fact that this is an opportunity to get you to fill in that survey, I want to give you a sense of what we'll be working through today. First up, we'll be joined by my friend Jared Leake, CEO of A2EP, who will give us a short rundown of why this research is so important and some of the previous work that A2EP has done on heat pumps. We'll then hear from Simon Ray from A2EP to talk about the modelling exercise I referenced earlier. And we'll close with an extended Q&A panel with the entire project team from across A2EP, EEC, and I think we've even got some bloke named Alan Pearce to join us for the chat as well. So to that point, there will be questions. We'll cover them off at the end. So if you've got questions as we run through the presentation, drop them in the Q&A tab at the bottom of your screen, and we'll do our best to get to as many of them as possible. So without further ado, let's get into it. Jared, do you want to jump in? And can I say it's very exciting to be doing our first live event together. Great to see you, mate.
Likewise, Luke. Many thanks for having us there and having us join you on this this heat pump journey. And just quickly, I'd like to acknowledge I'm broadcasting from Darramurrugal lands today in the northern suburbs of Sydney. Great to be here.
Fantastic. And I think you drew the short straw. So rather than just vamping up here, you've actually had to prepare a presentation for this session. So do you want to get into it?
Absolutely. I thought we'll guide some thoughts here initially with some slides. Yes, I thought I would start with the personal journey on heat pumps. Got to walk the talk here. So I've just had my first heat pump installed, water heat pump, just a month ago, and having some fun with that one. And but yeah, you can very quickly see lots of potential with what you can do with a heat pump in terms of using your solar and maximizing that and using it as a thermal battery. But in practice, that's not so easy. The trades are not up to the skills of how to connect it to the solar inverter. The installation was reasonable, but not really a high level. There's no real standards and performance tests and what have you to ensure that you're hitting the right mark. You can't easily set up a tariff optimization, and so yeah, you're open to a bit of bill shock potential if you were to, worst case scenario, use your hot water in the mid-morning and have the heat pump running through the afternoon at peak periods. So there's quite a ramp up here, even on this the residential side. Taking a step out, this is sort of our eye on the prize here. About 1,000 petajoules of energy is used for heating in Australia, and this is taken from that lovely ITP report that is commissioned by ARENA. And you can see on the pie chart there most of that heat coming from residential and alumina and non-ferrous metals, nickel and the like there. So we'll be taking all this past work, like what's been done by BZE and what have you, and putting this together to work out ways forward and understand barriers there. And part of this study is, yeah, how much can heat pumps do out of this, out of all this heating load? What is reduction in energy as you transition to heat pumps? Just exactly how much of that COP can we get to reduce the overall primary heat usage? How's that going to impact on emissions? Obviously, with the decarbonising grid to keep in mind, and the grid impact as well on this level of electrification. So I asked the question, why heat pumps? Why now? Definitely not new technology. Residential and commercial, decades, absolutely decades. If you consider it being a reverse cycle refrigerator and space heating, it's been around for a long time. Industrial sized heat pumps, and that's sort of above that 500 or so kilowatt size, they've been around in operation in Australia since 2012. So not a new technology by any stretch. But what has changed? So natural refrigerants are becoming more widespread with further usage of CO2 and further development of reduced GWP refrigerants. Importantly, cheaper renewables versus natural gas price. That's making a big impact on the viability for heat pumps. And also we're seeing the decarbonisation of electrical grid. And what is set to change? So we've got a lot of companies, businesses, councils, state government going for decarbonisation commitments. You've got reducing costs of heat pumps as the industry itself gets bigger. We're seeing costs coming down for standard units. We're seeing the need for increased flexibility of demand for the grid to be balanced out with renewables. And we're seeing high temperature heat pumps come into play, getting up to 200 degrees, probably still in the lab there, but 160 degrees certainly under demonstration for a decent size plant. And it's not just Australia doing it alone here. I mean, there's a very good report came out just a few months ago from IEA, their net zero by 2050 roadmap. And if I just take a couple of key graphs from that one, you can see on the one on the left, they talk about most of the investment for a net zero energy system is for electrification. In the light blue there, you can see how much that is taking up for most of the investment. And then if you look at the graph on the right-hand side, I've just drawn that right box around the low, medium temperature heating by technology. And if you look at the orange there, you can see that bar for heat pumps greatly expanding by 2050. And if I just take a quick guess at that, that's looking at about 30% of that heating load by 2050. So it's an enormous expansion of heat pump technology implementation. A2EP's done a fair bit in this space already, mainly in the industrial areas for food and beverage. Over the last couple of years, we've been working on a project with ARENA, sponsored by ARENA, where we've taken various sites and done pre-feasibility and feasibility studies. We weren't just looking at heat pumps, it was all sorts of process heating alternatives from biogas to geothermal, solar thermal. But certainly under that 100-degree temperature range, we saw heat pumps as being the most viable and economical industry technology to choose from there. A little bit of some basic results that we got from that was the relationship of electricity to gas price ratio. That does have a profound impact on the viability of a heat pump project. And yes, as I said before, as we see the renewable electricity price coming down, that's certainly changing the economics there going forward. A few other sort of key issues there is when you're getting into a decent sized heat pump is that number of hours of uptime. You know, you really want to be looking at sort of 4,000 to 6,000 hours per year utilization of that heat pump. Otherwise, the economics starts getting a little bit dusty. And also that ability to have site integration, and that can potentially give you that great heat source, improving your COP. So that was what we saw largely from the industrial studies there. A lot of other sub learnings from that as well, but that was just a few of the key ones we saw. We've also been doing a lot in terms of developing tools and sizing guides. And I think the spreadsheet on the right there is available on our website. If you need a ready reckoner, a very quick estimate of how much a heat pump, industrial heat pump that is, would cost, you can quickly put in some data there and get some operating costs and paybacks and COP data there. We also intend in this study to be building on the work we've done, developing a model for the New South Wales government on the impact of heat pumps on the electricity grid, and also allowing for different thermal batteries and the sizing of those and how that can have an impact as well. On our website, you'll find a lot more info, publications that we've done, a couple of key ones there, as well as recordings for different webinars we've done over the last mainly 12 months. So yeah, plenty of resources there for you. Just to let you all know, we do have a fair few webinars coming up in the future as well. If you go to A2EP website and go to the events section, you'll see this. So there is some 7 or so heat pump and process heating related events coming up over the next 6 months. A few of them are closed, like we have for aquatic centres. That's only a closed audience, and for abattoirs, but the majority of them are open to the public, and we certainly welcome people joining us there. So that's a bit of an overview of what we've done, and yeah, look forward to questions on that one towards the end. Thank you.
Beauty. Thank you, Jared, and appreciate you bringing a bit of the personal experience to the table. When I saw my personal journey with heat pumps, I thought you might be referring to some interaction you'd had as a young chap with a heat pump, but I guess the love affair doesn't go back quite that far.
No, it's only a few months. It took me a while to get it installed, but it's only just blossoming. It's only just starting, Luke.
Young love, I love it. Jared, we'll hear from you later on in the session in the Q&A, but it's now my great pleasure to welcome Simon Ray, who's a project manager at A2EP, is going to just give you all a bit of guidance about what we're seeking to achieve with that modelling exercise, and importantly some of the key inputs that we'll be looking to gather to ensure it's as robust as possible. Thank you, Simon.
Thanks, Luke, for your introduction. And as a quick introduction to the modelling side of the project, I am all about getting into plant rooms and getting my hands dirty, but I also love applying data to those situations. So this was a perfect opportunity. I've worked kind of alongside EEC in previous roles, even going back several years. And with A2EP, what we're really focused on is going maybe beyond the policy to the actual implementation. How can I take my my background with conversations with plant managers, maintenance managers, site managers, and actually see, is the theory and numbers, do they stack up, or is it some kind of practical relation that we would never get established if we were just looking at numbers themselves? So really just driving the policy, driving the research, driving desktop reviews in terms of gathering numbers. And essentially the federal government were looking obviously at emissions and looking at energy. So that's really the main drivers. How much emissions reductions can be achieved by utilising these efficient technology options, and what are the impacts across the country. And so to do this, it's very exciting, it's very interesting, and it's also rather daunting because for those of you who have done any modelling work, there is a phrase which is garbage in, garbage out. And what that's alluding to is certainly not, we're not dealing with garbage, but the quality of the output of the model is only as good as the quality of the inputs to the model. And this being a very relatively new sector in Australia, obviously what we come across fairly quickly is a bit of a dearth of data. So we'd love to be able to produce a highly accurate model, but what that relies on is having, for example, interval data for gas consumption and even thermal usage. And that's obviously more common for electricity, where we're talking about smart meters and sub-meters. But for gas and for water and even steam, that's much less common, let alone at a national scale. So probably my first call out is to anyone who knows of good high resolution data sets covering those items, please get in contact with us, and we would love to have further conversations. In terms of what we are doing with the model, as Jared mentioned, we have done a model already for the state government, DPIE in New South Wales, and that was really looking at the potential uptake of heat pumps and incentives through the energy saving schemes as to what might increase that uptake and what kind of numbers we'll be looking at. With the federal model, that's slightly different, but a lot of the inputs are actually the same. So for those of you that are familiar with heat pumps, you know that there's a lot of variation in performance. High coefficients of performances are often quoted, but one of the historical factors around heat pumps has actually been some uncertainty and some debate about their actual performance. And that can be influenced by a whole range of things, from the location, the operating hours, the peak temperatures, and the temperature uplift. Let alone the refrigerants, the insulation, thermal storage. And so what we're really doing is building all of these aspects into our model as submodels. So we're taking an approach where we have a very flexible overall model, and we're relying on the inputs of those various aspects to feed into the overall model. This is, gathering the data, I guess, is the first challenge, but You also think about the complexity in terms of, you know, a counterfactual situation when, for example, we might have a lot of luck in certain sectors, say, you know, councils and aquatic centres, you know, generally proactive in managing their energy use, probably a likely source to find some relatively good data about, you know, either the pre-upgrade situation where we're talking probably gas or electric resistance heaters, but even the upgrade solution where they may have already upgraded to heat pumps and have the data available in terms of evaluating how that upgrade went. But what we also have is a whole load of situations that we haven't got in the baseline situation. So, for example, one of those is thermal storage, which heat pumps are heavily reliant on because the oversizing of conventional hot water systems is, you know, fairly widespread, and with good reason, because it's cheap to do so. And why not be safe rather than sorry? You want to have that capacity so you don't run out of hot water. But with heat pumps, that's a slightly different situation where the incremental cost of implementation is very high. So your sizing of the heat pump should be very accurate. And what that means is that heat pumps should really be considered hand in hand with additional hot water storage. And where that's a slightly new aspect, you know, there is a challenge for us of modelling something that hasn't actually existed. Luckily, I do have a fairly extensive background in measurement and verification and various experiences in the state scheme, so that's all being put to good use. But we also need to consider, for example, the availability might lead to increased usage. So, you know, often we find in terms of energy efficiency, we can consider that as maybe the same output for lower energy or a similar output, similar energy for higher output. And that's certainly the case with energy productivity, where we're looking in terms of not only the energy reduction, but the product productivity, the output, the use of that hot water, or even the quantity and temperature of that hot water. And that means in the practical scenario of the model is that maybe once people have got highly efficient hot water, is that they actually use more of it. And is that more efficient? But that's something else that one of the challenges that we're trying to translate into numbers. And I will probably leave it there, because that's given me given you all, I hope, a quick overview of some of the inputs that we're doing and some of the challenges. But as of course the other gents have said, we're happy to take questions at the end of this session.
Hey, thanks, Simon. And I suppose in terms of the scope of our investigation, you and Jared have covered a lot of the territory. The other thing that we're drawing on very heavily is the international experience. We obviously have other markets, particularly in Europe, with much higher penetrations of heat pumps. Now, different variables in terms of climate and the like, but there's still lessons that can be learned from that perspective, but also in terms of the interaction with the grid, in terms of the skills and standards and supply chains that have developed in those markets. And so I suppose my message to folk on the call is that, as well as like the local experience and anything that can be shared on that front, we're also interested in an international context that we perhaps haven't managed to get on top of yet, that can support that data gathering exercise. All right. Well, I'll get you to stay right there, Simon, because we're now transitioning into our panel session. So I'll welcome Jared back, and I will welcome for the first time our three additional panelists. We have, of course, Alan Pearce, a Senior Industry Fellow from RMIT University. Welcome, Alan. It's great to have you here. We also have two EEC staff members. We've got Holly Taylor, who is, of course, Head of Projects, and Julianne Tice, who's a Senior Project Officer at the Energy Efficiency Council and is leading on much of the research and report writing for this project. Hello, Holly and Julianne.
Hello, Luke, and everyone else.
All right. Well, I might, while people are sort of cogitating, and we are keen to address any questions that you might have in the Q&A tab, I might put a fairly large question to you, Alan, just to kick us off. You've obviously been thinking about this topic for quite some time. Indeed, I was reflecting with you earlier that the kind of the explainer on heat pumps that you wrote back in 2016 with Jeff Andrews is far and away the most popular article ever on the Energy Efficiency Council website. But sort of taking that piece that Jared flagged around the decarbonisation potential, we're obviously all thinking very deeply about that topic today of all days with the release of the IPCC report, with some fairly stark information around the rate at which we need to address the challenge of climate change. Where are the big opportunities, and what role do you see heat pumps playing in the decarbonisation journey that we need to travel here in Australia?
Well, they certainly have plenty of application. I'll just pick on a few because you can go on and on here. But one thing is that we're seeing increasing concerns about shortages of gas supply in the southern states in winter as the Bass Strait runs down. And so clearly heating of buildings by gas is a very good area to focus heat pumps on. Because essentially the biggest usage is in winter. And of course, we know that with our very inefficient buildings, there's lots of things to do with heating, certainly making sure we deal with the building as well as the equipment. Hot water in the domestic sector is interesting too, because something like 15% of household electricity is used by electric hot water services. And a lot of that's happening at night when there's actually no sun. And even a lot of it's in winter when solar thermal hot water services don't work that well. So the heat pump, which is pretty stable in its demand for energy over the year, is pretty attractive there, especially because as Jared said, and Simon, you can use thermal storage to shift around the time when you run it. In terms of industry, again, as Jared showed, there's quite a lot of heat that heat pumps could deal with. And again, what we're seeing here is that the recent increases in gas prices for industry, and importantly, the volatility of gas prices, particularly just in the last few months, is essentially causing quite a few industrial consumers to think pretty seriously about where they're going. And at the same time, as we see more modular technologies and distributed manufacturing as well as distributed energy, there's quite a lot of scope for areas that are off the gas grid to use heat pumps for industrial purposes. And yeah, so lastly, I guess it's also interesting with agriculture. Dairy farmers, for example, have very peaky loads, and a lot of them are right near the fringe of the electricity grid and have real problems with limited supply. So that's another area where heat pumps really have a big opportunity.
Okay, thank you, Alan. I'm sure we'll circle back to some of that detail as we work our way through. Julianne, I know that you've been reflecting on some of the barriers that we will need to reflect upon and address as part of this report. Did you want to just quickly run us through some of the top ones that you've been digging into over the last several weeks?
Sure. Thank you, Luke, and thanks everyone for joining us today. We've uncovered quite a few barriers already just through the preliminary research. This makes it not quite a surprise that heat pumps haven't really taken off yet in Australia, but hopefully that will change in the near future. Jared did allude to some of the barriers that we face in the residential space, but just to add to that, the consumer perceptions that heat pumps don't work in winter, or that they're too noisy, or somewhat lagging perceptions that people have maybe from older models that they've had experiences with, and that's something that we'll need to overcome in the future because heat pumps have improved greatly, but people may not be aware of that. They may also not be aware if they have a reverse cycle air conditioner that can heat their home as well as cool. So a lot of the consumer perceptions that are out there might need to be changed, but as well, there are insufficient standards for some types of heat pumps, particularly for commercial and industrial heat pumps. They don't have sufficient standards in terms of production of these units and their performance levels, and these are things that will need to be put in place so we can ensure that heat pumps that we are installing are of sufficient quality, that they are actually reducing energy consumption once they're installed. There are also building regulations in place. I'm thinking particularly of Victoria that mandate gas water heaters. These were put in place in around 2009, and they had good intentions when they were implemented, when the electricity grid had higher emissions intensity, but they're no longer serving us as renewables have penetrated the electricity system much more than they were at that point, and as we're working towards decarbonization. So older regulations like that will need to be changed in the future as well. And in the commercial building space, the amount of space required, it's quite a simple thing, but the amount of space required for heat pumps can be up to 4 times what's required for traditional boilers and chillers that most commercial buildings use now. And for existing buildings that just don't have the space, that might be an insurmountable barrier. But for designing new commercial buildings, we can make sure that they have enough space to install something like a heat pump. High upfront costs, another quite simple but important barrier, especially for low-income households who may be wanting to install something like a heat pump water heater or a reverse cycle air conditioner. If they don't have financial support to do that, it might just be something that is impossible for them. And now something that I also wanted to address in terms of consumers is that it's another quite simple barrier is that, say, if you have a water heater that dies, what you want to do immediately is replace it. You don't want to be without hot water for more than a day or 2 max. So if you're going to replace that, if you haven't already thought to replace it with a heat pump, you're probably just going to go for like replacement. And if you don't have an installer who is familiar with heat pumps and willing to recommend that type of technology, then you might just be replacing with say a gas water heater if that's what you had previously, and that's locking you into gas for another 10, 15, 20 years, which is the opposite of what we want. So we definitely want installers to be more comfortable with heat pumps, how to install them and recommending them to consumers. So I know some previous work has been done by some community groups that has found that an intermediary between installers and consumers that is able to determine that a heat pump is appropriate for a household and can work with the installer to match those two up and recommend something like a heat pump is definitely beneficial. And indeed, we've done some research in Germany, and their training regimes with installers there, and they're even pushing heat pumps in households to decarbonize their residential building stock. And even one of the countries that is leading in this space still has installers that are not quite confident with the installation of heat pumps. So that's just what the research has uncovered so far. I'm sure there are more barriers out there, but hopefully we can find some solutions to overcoming these barriers.
I don't know, Julianne, that sounded pretty comprehensive to me. It was a pretty good rundown of the various barriers. I suppose the message out of that is where there are reasons. There are reasons why heat pumps haven't taken Australia by storm in some sectors and for some applications. But there's also very good reason, as Ellen outlined, to overcome the ones that don't need to be there. And certainly when it comes to things like skills and supply chains, so these are things that an application of attention can certainly address. Just on that skills piece, Holly, before I go to the various questions that are emerging in the chat, I know that you've been doing some broader work on skills, which, this topic of, the skills needs for electrification, where that makes sense, plays a role. Did you want to just speak to that broader context briefly?
Yep, thanks, Luke. So it's really important to note that there's actually a lot of research and work being done on skills and training in Australia at the moment. You've got a lot of the governments looking into it quite closely because of their commitments around net zero, and indeed even the federal government, which hasn't made as strong of a commitment, is supporting this space. So one clear way that they have been doing that is through the Race for 2030 CRC, which has an explicit work stream on developing the future energy workforce. There's an interesting piece about this research is it's looking at what do we need for our energy workforce moving forward so that we can effectively deliver the energy transition in Australia. And some preliminary research that's been done through RACE that the EEC was involved in with A2EP and with a bunch of other industry associations and universities has been on, what actually are the barriers to getting our workforce upskilled. So it's really interesting to look at that a lot of the issues aren't technical issues. So a lot of the technology is actually relatively simple and we understand it. The problem is that the people that are on the ground don't necessarily understand those benefits. So one of the potential opportunities to these barriers is looking at training and education programs, not necessarily for the end user, but for the intermediaries. So we're talking about the people that are selling air conditioners in Good Guys. We're talking about the plumber that's coming around to fix your hot water system when it breaks, and upskilling these people and supporting them with understanding the opportunities is a clear opportunity. So the research that's already been demonstrated is going, well, how do we move from not just upskilling, say, the traditional energy services workforce, but actually moving into the wider economy of the people in businesses that are involved with managing energy, and the intermediaries that might be those people that are selling products, but it also might be the financier. It could be the business's banker, or it could be the resident. So a home, it's really useful when banks are starting to roll out programs where you can get lower interest loans or no interest loans on upgrades to your home that support the energy transition. But do our bankers on the ground that are actually talking with the householders know that? So that's one of the clear opportunities that research has been demonstrating moving forward, and it's definitely something that we'll explore in more detail in this work.
Good. Well, thanks, Holly, and thanks to all our panelists for their comments. And the comments are going wild, so I want to sort of jump into those as quickly as we can. And I'll admit I'm scanning, so if I don't characterise your question exactly correctly, my apologies in advance. But I want to kick off with this a recurring theme I'm seeing in the comments, which is around refrigerants and their role in obviously global heating, something we need to be very conscious of as we sort of seek to expand the rollout of this technology. Alan, did you want to comment on how we should be thinking about the role of refrigerants in all of this? And because they're obviously something that we'll be addressing as part of this report.
Yes, well, possibly Jared can add quite a bit to what I might talk about. Look, there are several natural refrigerants, as they're called. Carbon dioxide, hydrocarbons, and ammonia are most common. They are quite efficient, but they each have their own issues. And I think this is the problem, is that globally people are working on low global warming potential, as they're called, refrigerants of all kinds, including synthetic ones. And just about all of them have strengths and weaknesses like toxicity or flammability or things like that. But a lot of them are actually more efficient than the old refrigerants. And it's really a moving feast. I mean, for example, most fridges sold in Australia for homes actually use hydrocarbon refrigerant, which is essentially pretty much LPG, but it's a very small amount of that refrigerant. So we've actually done quite a lot of changing as well. So there are different refrigerants for different purposes, but I think we definitely have to deal with it. But at the same time, we need to consider things like if you've got a factory sealed unit, like some of the heat pump water heaters, the CO2 ones, then the leakage rates from them are very low because they're properly sealed. Whereas a lot of the commercial industrial systems have lots of connections and actually have quite high leakage rates, so that the global warming potential of the refrigerants in them can be really significant. So it's a very mixed area, and look, the Australian refrigeration industry is having lots of debate, and there'll be progress. I think For example, hydrocarbon refrigerants, I think, probably have a bigger future than a lot of people realise once we put their flammability issues into better perspective and put in the processes to manage them. And they can do a whole wide range of temperatures, which would be really good.
And Jared, did you have anything you wanted to add to that?
I think that was a great summary. Thanks, Alan. I think I'd agree with this potential for the hydrocarbon and refrigerants. I heard it put recently, it's like, well, you drive around in a car with 60 litres of highly flammable hydrocarbons in the back there in a moving vehicle. 600 grams of refrigerant, of hydrocarbon refrigerant sitting in a heat pump, really is that what's the right risk here? Understanding of that. But we certainly, we've very much like energy efficiency being the no regret investment, Luke. Natural refrigerant certainly seems like the no regrets way to go. And so ammonia, CO2, propane, or some of these other very low ones are certainly the way to go.
Yeah, and the only thing I'd add to all of that is that, as Alan said, there is a lot of interest in this topic overseas. And I caught up with our friends at the California Energy Commission a couple of weeks ago, and they're leaning heavily into heat pumps in California. And this is something that is very high up the agenda. And when California takes something on, it tends to get solved, and it tends to be proliferated fairly rapidly across the industry. It's such a big economy, and so I suppose any efforts that we have in this space will be supported by those global efforts as well. Again, scanning, trying to pick out the themes from the chat. There is a bit of a discussion underway around the opportunity to control the load associated with heat pumps, to shape it, to, as I like to say, follow the sun. The opportunities for smart controls to allow us to play with set points and ensure that it's interacting with the grid in a smart way. I'll throw this open to the group. Is there anyone that would like to comment on how we're grappling with that as part of this report?
I'll say that we'll look at that as part of the modelling to understand how that load shifting can work. Certainly it's a case of being able to concentrate the usage of that heat pump for residential between 10 and 2. That's just such an easy sort of outcome, when the solar's are maximised. In industrial cases, certainly the technology is coming, is here and now, where you can have that forecast of a day or two ahead and look at whether or not you should be having your hot water storage tank at 60 degrees today. Maybe you've got a demand of 60-degree hot water, not much solar happening. Okay, we'll just keep it at 60. Maybe there's a case of really good solar today, but going to be terrible tomorrow. Great, take it up to 75, 80 degrees, that sort of thing. The technologies are there from the likes of Glacium doing that one. So we certainly see that that's coming, that evolving, and we'll bring that into a little bit into the modelling in terms of day to day, but not the forecasting ability. We're not ready for that.
Any other thoughts on the flexibility piece? Well, I'll just add then that it's something that we're looking at across a range of appliances in terms of how you create the platforms and certainly the DRED enabled devices is a pretty hot topic here in Australia right now. So it certainly applies to heat pumps as well as things like pool pumps and things like electric vehicle chargers. We find ourselves in an interesting spot in Australia, being a small market, but in many respects at the bleeding edge in terms of the rollout of renewables. And so places like South Australia want this capability yesterday because of the challenges they're facing in the grid. So I think the opportunity for this report is to get some really solid guidance from what's being contemplated overseas. I suspect we'll be able to get to that brave new world a lot quicker, the more that we can align with trends overseas, and that's a balancing act. It's a challenging one for us here in Australia, but one we need to get right. There's a few questions here on incentives for heat pumps to support the rollout. There's a range of angles that are being contemplated here the opportunity for our various energy efficiency schemes to do more to support the rollout. There's a note here around the role that STCs already play in this space. Any comments on the policy levers that we're contemplating when it comes to supporting the rollout of heat pumps?
Oh, well, maybe. Well, look, it's a very, very tricky area because in many parts of Australia, we have a lot of historical policies that, for example, in Victoria have been based on gas being much lower greenhouse impact than traditional brown coal. And the new technologies that are emerging are moving really fast, and it's hard to keep up with it. And if you look at the Victorian Energy Upgrade Scheme, is quite interesting at the moment, because what they're now doing when they're looking at setting up their incentives is actually looking at the lifetime average greenhouse impact of the electric technologies, because I noticed someone's talked about 1.13 kilograms per kilowatt hour. Well, we're more like 0.85 or something, or 0.8 at the moment already. And under government scenarios, it's dropping very fast. So one of the reasons why the Victorian government is starting to offer some incentives for heat pumps is because looking at that lifetime climate impact, they're starting to look reasonably good. And of course, what we also see is that a very large number of households and businesses are now investing in pretty large rooftop solar systems. So if you do run your equipment at the right times, you've got zero emission electricity. We're seeing the Green Building Council, for example, working with leading builders to come up with zero carbon homes, which will have, you know, a combination of renewable energy and storage and heat pump technologies. So everything's moving really fast, and fundamentally the issue is, in Victoria anyway, we've got emerging problems with winter gas supply and uncertainty and potential price issues. We've got the fact that the future for electricity is zero emission. It's a question of how soon. And so these are the sorts of things that are coming through. And even for some of the households that are going off gas, I mean, when I disconnected from gas, I saved myself $300 a year on the fixed supply charge for gas. I only now pay one really large fixed supply charge just for electricity.
Yeah, no, absolutely. And I suppose there's a couple of things coming out of that, Alan. Firstly, you know, there are some national issues, but there's also some issues state by state, depending on, you know, the climate and the existing infrastructure that we're grappling with. But there's also, you pointed to the relative emissions factors for gas and electricity. I wonder, Jared, if you wanted to comment on the question there from Gareth Davies on that topic.
Yeah, and it's a great one to bring up, because you think, well, are we really moving forward here with heat pumps? And I think you've just got to look at the rate of decarbonisation of electricity grid. I think it was quoted there, Victoria's CO2 emissions per kilowatt hour, 1.1 or so, but you know, it's coming down very fast. And you know, I think the latest AEMO, you know, we're looking at 0.5 pretty soon. So let's say it's 0.5 pretty soon. Then you look at the one from natural gas of 0.18, and so you've got a factor of sort of 2 to 3, and that's exactly where the COP comes in. So if you look at you take the gas heater, probably operating around about 85% efficiency. So that 0.185 goes up to, let's take that up to 0.22. And then when you compare like for like with your COP of the heat pump, times it by 3. So you're certainly well ahead of the game there. And so there's not many years before you're definitely ahead of the game when you're using a heat pump, but a valid concern. And I think you can even see there's the examples there of we had Mike Siddon's comment how he's gone from 18 or so kilowatt hours down to 3 to 4 kilowatt hours when he's changed from a heat pump. So yeah, electrical resistance heating, just such a no-brainer, easy, away you go. Natural gas, yes, as the grid decarbonises, and that COP kicking in, certainly a winner there. Final thing to comment on that when it looks to industrial. Everyone, when you talk about what's your efficiency of your gas system for industrial, you'll usually hear the term of what is the boiler efficiency. And someone say, yeah, at best, you might hear 85, 86%. Usually it's about 80, they quote the boiler efficiency. However, an overall steam system, by the time you allow for the water treatment and the water losses and condensate losses and blah, 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 overall steam efficiency in such a system would be closer to 60, 65, maybe even lower. In fact, we've seen cases, around 30% efficiency. It's really, really poor. Sorry, one more point to add. That 0.185 of emission factor for natural gas doesn't allow for fugitive emissions for natural gas. That's purely a stoichiometric burning type ratio there. If you look at the fugitive emissions and what's coming out in recent reports, it's not this 1 or 2 or 3%, it's much higher. So that methane getting into the atmosphere from these coal seam methane exploration, much, much higher. And so they haven't even included that. If we included that, 0.185, where's that going to go? That's going to go much higher.
Look, it's a great point, and it's something we're very conscious of, right? It's that tipping point where heat pumps are a clean win, not just from taking into I guess those life cycle emissions, but the kind of the story that is being contemplated for governments looking to make some fairly significant shifts. You can see with Victoria at the moment, their gas substitution roadmap starting to grapple with these issues and their vexed issues. And so we're very conscious that this study is taking place in the context of a broader debate. There are a lot of other pieces of the puzzle that governments are going to need to put together to chart that emissions reduction pathway. Our task with this heat pumps report is to make sure the heat pumps data is really solid, so that that piece of the puzzle is solid, and we can rely on that piece of the puzzle playing its role in the broader decarbonisation trajectory. Now, again, scanning questions, apologies, I'm kind of skating across them here, ladies and gentlemen. There's a good one here though around the opportunity for manufacturing here in Australia. Obviously, a lot of interest in supporting our manufacturing industry. There's a big focus, I note, in manufacturing in the context of appliances, renewables, the way all these things interact, and we can make that transition to a zero carbon world. Is there an opportunity on the heat pump front for us to lead in that space?
I will say yes and no. When it comes to an industrial heat pump, you're looking at local content around 50%, and the controls over that need to be developed to interact with solar. So we could be a powerhouse for how to do those controls and export that for sure, and those controls also across residential and commercial as well. The componentry and the manufacturing componentry, can we get critical mass in Australia for all the machining of compressors and things? That's questionable. Can we certainly assemble the components and put them together? You betcha. And that's a huge potential for manufacturing jobs here in Australia. So I'd say, great potential just for assembly of components and the installation work. Installation and putting on skids, that's 50% of the work or more right there. So you're looking at a huge amount of local content and jobs growth here.
A lot of the heat pump water heaters too are using locally made tanks, for example, that can be amplified. And again, governments could incentivise local tanks.
That's probably a really good thing to point, is that broadly Australia's manufacturing industry often doesn't develop the whole thing. So as a good example, we no longer manufacture cars in Australia, but we still manufacture a lot of components of cars. So to Jared's point of certain areas, can we get scale that some of our competitors, specifically in Asia, can get? No, we can't, but we are able to specialise in certain areas. And the capacity for us to service both the potentially huge market in Australia, when you're looking at what actually needs to happen with the low quality of our building stock here and what needs to happen, and also the low performance of our industrial energy management, means there is a lot of opportunity but there is actually still potential to be exporting certain things out as well, because there are niche places where Australia has quite skilled people. So as an interesting point, Jared's point around thinking about the supply chain and the putting things together, the reality is there's still a bucket load of people in Australia that used to work in the manufacturing industry that was putting things together. So there's a bucket load of people in Australia that have those skills, and we're just not utilising them. So with a little bit of creative thinking from government, we actually really could boost local manufacturing and also, you know, really bring that Aussie made back in spirit and in action.
It's a great point, Holly, and part of your answer sort of touched on the role that a heat pump plays in kind of a broader building or a site. And it's something that everyone in this call is very conscious of. We're not interested in just plonking in this technology and just ignoring kind of the building or the factory that it sits in. It's inevitably going to be about how you integrate that in, whether that's about thermal performance or you know, process optimization, you know, thinking about that ecosystem, but then also thinking about the kind of literacy we need to build among potential customers for heat pumps about the benefits that they have. All of this is in the mix, but we're almost out of time, and I have promised to throw to Julianne at this point to make sure that you were all appraised on the call about next steps and in particular the key data sources that we're looking for you to share with us so that we can make this report as impactful as possible.
Thanks to everyone who has filled out the survey so far, and apologies to anyone who has had difficulties with that, but we will be sending it out more widely tomorrow. So if you haven't had any issues, we'll make sure those are resolved so you can hopefully try again and it will be a little bit more smooth. But for anyone who has filled out the survey, I unfortunately don't have any visuals, but just to let you know the most significant barriers and potential opportunities that were identified, which could be exciting for everyone to know the results of the survey. The number one identified barrier is end user awareness and or perceptions, which I did note in my barriers section. So that's something, a very important and interesting part we'll be looking at through the report. And the most significant opportunity is government incentives. So no doubt that is important. But we'll see how that goes in the future.
So Julianne, people don't know about the heat pumps, and we need to give them money to do something. That's the guidance from our expert group.
Exactly. Simple solution, of course. And just to reiterate the data sources and case studies, other publications that we're after, if you do have anything that you are able to share with us that you think would be helpful in our research, that would be greatly appreciated. So in terms of data, I think Simon alluded to this in his talk, but if you have any data sources that would help us estimate the penetration of heat pumps in the various sectors that we're looking at, or any energy consumption data or emissions associated with heat pumps, that would be really beneficial for us. As well, any case studies with cost and or emission savings information, those could be domestic or international, either would be really useful. And any relevant publications that you may have available to share that would be useful for us, that would be really appreciated. You can pass those along to either Simon or I, and HVP has some events coming up that are in this space, so if you'd like to check those out, you can have a look at that link there. And thanks everyone for joining us. I'll pass back to Luke.
Thanks, Julianne, and thanks for all your hard work, and indeed everybody across the project team. It's been a rollicking first few weeks of this project, and I'm very excited now that we've convened this this heat pump expert group, 150 people at the peak tuning in to share their thoughts, and an incredibly vibrant comments section. I'm really excited to be connecting with all of you that are so passionate about this topic. I apologise if we didn't get to your questions. Rest assured, we've logged all of your comments and questions, and we'll be working through them over coming days, and there'll be further opportunities to engage with the project, as Julianne says, and anything that you can do to support us to make sure that this report lands where we all want it to would be deeply appreciated. So from me, from Jared, from the entire project team, thanks for sharing an hour of your day with us, and stay tuned. There'll be more where this came from. Thank you.